Hello, hello.
Yeah.
All right, greetings everyone. Thomas is my name. My full name is Tomas Ersson, and associate professor at SLU as well, but at a department that's called School of Forest Management, and it's in a town called Skinnskatteberg. I'm in Sweden, and I've been here then invited to talk a little bit about the silviculture side, and to give sort of a Nordic perspective. I will mostly be focusing on the Swedish perspective, but albeit looking at as well a bit at Kalle's country. So who am I? For those of you who don't know, I'm a Swedish Canadian. I grew up in Canada and started my forestry career there, and then have since then moved to Sweden and working sort of in the last 20 years about in Sweden. I did have a time when I was also in South Africa as a student, so I have some networks there. I started manually working in the forest and then have progressed, you could say, more and more towards the desk, and that's where I am mostly today. You've heard now from both Kalle and Ola about the Nordics. So what we can say is that it's the boreal forest. I don't have to perhaps say so much more about that, but and you also have seen that Ola mentioned that the rotation is about 100 years, but we do have shorter. We have in extreme south of this area, such type here, forests, broadleaf forests, and in the north going on to the tree line. And both forest types exist, but most forests are a mixture of these two photos. We look at just at the ecology of Swedish forestry, Ola was mentioning, he has sort of the Nordic or the northern perspective. I myself is situated here in the middle where the star is. And if you look at the south, well, if we first look at the north, it's a bit different, rather low site productivity. Most of the other countries around the world will have a higher site productivity. We'll have generally cold soils, which from a silvicultural perspective is important to note. And we have things like reindeer husbandry, which exist in the north. Whereas if we look in the south, we have much higher site productivity, generally 8 or plus cubic meters per hectare per year. We don't have snow basically in the south, and we have pervasive browsing and insects and such that from a silvicultural perspective are quite different sort of from the issues that are faced in the north. And of course here in the middle there will be some sort of a mixture of these two extremes. Typical forest landscape in Sweden will look like this. And we have basically three type of species that we work with, at least from the Swedish perspective, and it's pretty much the same in Finland. But we also, at least in Sweden, have some plantations. We have another exotic species coming from Western Canada. Myself grew up, the Pinus contorta, which exists in plantations in the north. So we do have some plantations. Otherwise, we mostly work with sort of the forest as exists, the in-house forest or the domestic forest. Ola mentioned that we generally have rotation forestry, and with rotation forestry, we have in general 6 silvicultural tasks. And site preparation being the first. If you think about the photo that or the figure that Ola mentioned, shown, then we'll start with site preparation, and it's generally in the Nordic context, it's mechanical. You'll have site preparation in other parts of the world, which might be chemical or something like that, but we just do mechanical site preparation, and that can be abbreviated MSP. We might do some regeneration through direct seeding or sowing, and then it's generally something attached to some sort of a site preparation vehicle. By far, the most common silvicultural task, or at least regeneration task, is tree planting. Then we'll have this thing called pre-commercial thinning, which is a thinning where we don't harvest any of the wood. And it's generally done, as you can see, motor manually, and it's abbreviated PCT. Commercial thinning, that's where we sort of do some type of thinning, but extract the wood for income or for industrial purposes. And it's generally done with some sort of a machine. And the last task, which most common task, we have other tasks as well, ditching or something like that, ash fertilization or something like that. But most of the time it's fertilizing with nitrogen, and often it's done using some sort of a tractor in these thinning forests. So these are the silvicultural tasks, and basically in the Nordics, we're interested in mechanizing this, and of course you could ask yourself why do we want this? Ola mentioned, why should we be doing things? The main reason why Nordic forestry is interested in mechanization of silviculture is the threat of labor shortages. We have lots of silvicultural workers that come from Thailand to especially northern Sweden, and this is an example of how labor shortage of domestic workers is a fact. And when I mention all, these are all the tasks, those 6 tasks that I showed on the previous slide. But mechanization has also reduces the silvicultural task of these 4 tasks: mechanized site preparation, MSP, seeding, thinning, and fertilization. So here, by using machines, we lower the cost of fertilization. But it can also improve the continuity among silvicultural workers, and we noticed that if you mechanize silvicultural tasks, then you have a chance that you might year after year, because it's a seasonal work. We generally do silvicultural tasks not in the winter, but sometimes, but generally it's a seasonal work, and this will then improve continuity among the workers. We will also generally increase the work quality. This is at least the case with site preparation, seeding, and planting. So regeneration, it improves the work quality. And there is the potential for technological advancements. And we've noticed that in generally, at least the manual tasks have sort of plateaued in their advancement of technology, whereas with those tasks that are mechanized, we do have a potential for advancing technology more. And this can also then alleviate, or they can lead then to that we have less labor need, and therefore a less threat of labor shortages, because we need less labor in general. So these are the driving factors behind mechanization. And just to give you a bit of a visual examples of these massive machines that do the MSP, we might have 2-road machines, we might have 3-road, and we also historically have had 4-road machines. These are called disc trenchers, or they might be, often they're dragged behind the machine, not dragged, they're carried, but working behind the machine. Sometimes they might be mounted in the middle of the machine. These 4-row disc trenchers are pretty much phased out. They were just too big. So there seems to be some sort of a limit, at least to how the silvicultural context is now in the Nordics in terms of clear cut size and what we leave on the clear cuts, the retention, that we've reached some sort of a limit in how big the machines can get. But there are many others. We have excavator-based. We might have mounders. There are 2-road. We might have 3-road. Here we still have 4-road mounders, and these are because these are, you can say, less. They require less tractive force than the disc trenchers, and these arms are sort of, I guess, a bit more agile. So we still have 4-road mounders, and we might have other types of implements as well. If we look at the other tasks, the other 3 tasks that have been mechanized successfully, you'll see that the seeding machines generally, like I say, are mounted on some sort of a site MSP machine, and then they let the seeds out just behind these devices here. Might be working with mounder or disc trencher, but in the end, there's some sort of a device where the seeds are dispensed one by one, and these are mounted on sort of behind the cab. If we look at commercial thinning, it's been successfully mechanized since at least maybe the 80s or around the 90s, and we generally have smaller sized harvesters. Fertilization can be done either through the air or via the airborne, like very common with helicopters or tractors as well. And so there exist basically manual examples of all these things, seeding and thinning, especially in the southern Sweden. But in general, you could say that most of it is carried out as these pictures are shown. Ola mentioned that tree planting and PCT has been more challenging to mechanize. So if you look at all the work that's been done in the Nordics, pretty much, not all, but most of it looks like this, with either planting bare root stock with some sort of a hoe, or using some sort of planting tube, and where you plant containerized seedlings. And the tasks with PCT are generally motor manual. They can be done manually as well, or sometimes with machines, but in general, this has been challenging to mechanize. But if we look at especially at the effort around mechanizing planting, we'll see that we have a long history. We've had many different machines through history, and especially from the 90s, we had some sort of a machine called a Silvanova, and this was the most successful machine. Today in the Nordics, we have mostly boom-mounted devices on tracked excavators, and very little. A bit is done in the south Sweden, but there are more in Finland. And most of the time they have these different types of devices, which are shown here. Lately, we have had a modern Silvanova that's called the Plant Max, and it operates in northern Sweden, you can say. And we have 2 of those machines that have been purchased just lately by a forest company called Holmen. This machine has we've studied the planting quality, and basically you can see that it does do more poorly than manual machines, or manual planting, but in general the seedling quality is quite acceptable. So they'll look like this perhaps when you're planting pines in northern Sweden. When we first looked at the machine, we were looking at about productivity around 1,200 seedlings per hour, but nowadays they're reaching around maybe 1,800, even more seedlings per hour. If we look at just if we take that study where we looked at how many were adequately planted, we'll see that if you were averaging around 1,200, you're still planting around 900 seedlings per hour that are adequately planted. So these are quite high numbers, and that's why this machine has been successful. One of the main challenges of getting sort of a higher productivity has been this seedling handling and getting a cost-efficient sort of system around this. You can see that there's lots of seedlings being used when you're so highly productive, such a machine. And it's a task which has to include a lot of seedling handling to get sort of the seedling to the end of the planting tube here. And this has been it's been challenging because there's so much seedlings being produced per hour, so there's a lot of costs for this machine, at least in the Nordic context, where it was around the seedling handling, and that has been sort of a bit of a focus on my research lately. If we look at future development here coming up with mechanized tree planting in the Nordics, well, we've seen a lot of different activity in the last couple of years. We've been seeing better crane mounted planting devices like this one here, which can take more seedlings, and it's using some minor adjustments. We've seen information system, for example, this Asta system from Risutech. We've had these visionary things where you've been looking for autonomous planting, which Ola mentioned, this auto-plant platform. We've had this project in the southern Sweden operating in the South Swedish context, where you have smaller clear cuts, smaller, basically less snow and all that kind of stuff. So they've been looking at trying to produce a smaller machine, which is suitable for this context. It's the Brasat, as Ola mentioned. Some of the most promising development for mechanized tree planting in the Nordics has been sensors. So thanks to the in general technological advancement of sensors throughout the globe, we've been able to sort of getting a bit more intelligence in how the machines can find a planting spot. So there's been a lot of work around sensors, and that's probably where a lot of the development in the future will be. If we look at mechanized tree planting globally, it's still a lot of technology that has its roots in Sweden and Finland. So we've had a Swedish developer focusing on plantations in the tropics, the tropical plantations. So you have sort of maybe a two-headed sort of device that's mounted on excavators. We've also had another manufacturer which have been doing something similar. We've been looking at other manufacturers also coming from Finland. These are all Swedish or Finnish manufacturers looking at trying to increase sort of or to better the seedling loading or the seedling feeding of the devices. We've been seeing that the plant max has been quite well taken, quite well commercialized in Brazil. So it's been sold many units to Brazil, working in that plantation context. We've also seen development taking place in South Africa from the equipment manufacturer Novelquip. And we've been seeing also another Finnish manufacturer looking to introduce some sort of a continuously advancing tree planter for the plantation forestry. And we've also been seeing some Brazilian-made units, which combining these bracket planters, but with in a context of the Brazilian plantations. So at present, 2026, this is sort of what's been happening globally, and with a focus on the tropics. So to conclude, there are still many opportunities to increase the productivity and to lower the cost of silvicultural machines. We've been seeing that this technical advancements, especially around sensors and such, there's lots of opportunity here. And the trend to find labor is as at present at least becoming scarcer. So yeah, especially the interest in mechanized tree planting is increasing. We are seeing that throughout the Nordics, even though the cost efficiency has been sort of going up and down. More and more interest is being expressed. And this cost-efficient seedling supply, it's challenging because the seedlings might come in a box like this, or there might just be so much need of seedlings that it's a tough job to keep these little delicate seedlings alive within automated or at least a mechanized system. So that's challenging. All right, so thanks. So get in contact with me if you want to find any more information regarding mechanization of silviculture in the Nordics. There are my coordinates. Thank you.